I should probably unmute myself. Hello! Hello, everybody. How are y'all doing? Welcome back. Thanks for coming to join me today. Gonna be doing some more hackmud. Hey, Jorstar, what's up? How's it going? Alright, so, we left off in kind of a funny spot last time. Oh, you're getting ready to install Arch. Interesting. Arch. I've heard good things about it. Howdy, FreeFrag. How are you? Thanks for coming by. So, actually, before we recap, I think what I should do is get the scraper started on something because that can take a little while. So, let's just very quickly go and grab an NPC here. Show.npcs. Whoops. Somebody broke show.npcs. Smork, you missed the start? You did not miss the start. We just started. You missed me accidentally saying hello to everyone whilst muted. So, so show.npcs is busted, which is funny because that just goes to show why I don't like relying on other players' scripts for my normal processing. So, I am going to have to go and figure this out myself, I think. We'll try it one more time. No. So, scripts. Let's see if I can even remember how to do this. Scripts.lowsec. And then I have to join this sector. Oh, I don't have any of my chat macros here, so I'm going to go copy them. So where we had left off was the tier 3 scraper was working, and then we switched to a snow corp, light.corp, and realized that the menu can be actually significantly different. The primary thing is that the menu options and the keyword can contain underscores, but also the menu parsing is a little funny too. So I fixed that off stream, and that's pretty much as far as I've got on my own. So I think we're going to have to figure out what we do next, whether that is going and doing some lore stuff for DataCheck v3, if it's trying to work on one of the tier 3 locks that we basically are stuck on all of them, or try to break this encryption thing. So I don't really know how to approach any of those options, so we're going to have to maybe just pick one. Anyway, let me get these chat macros set up so that we can more easily join and leave these sectors. Yeah, I guess like that. I guess that's all we're gonna do here. So we're gonna join this, and we're gonna do scripts.lowsec. Oh yeah, and then we're gonna do sector. I don't know if that's how you do it. Yeah, that's how you do it. So some of them I recognize. Hey, there are my ATM scripts. That's funny. So some of these I recognize, right? Actually, it's very interesting because I think that's the first time I've seen one of my own scripts in a sector like that, though I haven't really been looking. Buy.market. Alright, so archaic employee login, we know that's one. Light.priv as well. Snow.emp login. Halperion.private. Halperion. See, the problem is because I'm not 100% sure on the spelling. I mean, core.private is obviously one of them. So we'll go do that one. So let me just get my specs up here for Zyger. Okay, and we do T3 scrape, Zyger.T3 scrape, and we will target core.private. Oh yeah, we'll have to clear our token. That's one thing we haven't done yet, is we have not actually, we're returning the logs before we remove it from the database. And that's because, well, we're not done yet. So, all right, running this the first time, it should find the username no problem, and then get stuck on some pin, 100. I think it was Flux that was saying they scrape in batches of like 120 or something to avoid the garbage collection. So I set mine to 100, so it does at most 100 pins per run, and I haven't run to the garbage collection since. So that definitely did help. So thank you for that, Flux. All right, so we will run this once more, and then we'll auto it. Okay, so while that's running, so yeah, we're kind of stuck somewhere where we're gonna have to start doing something difficult. Either the lore exploration. I'm inclined to say that we should try to figure out this encryption, because you know, we can figure out all the locks, but if we don't know how to get a location, it's basically unusable. So yeah, so I think we're gonna have to do that, and this might involve a lot of Googling. I think I have to just, I think what I want to do almost is like Google, hey Raven, good evening to you. Good evening to you, friend, and thank you for coming in. I think we're gonna have to Google like step-by-step decryption. How to encrypt and decrypt using RSA step-by-step. Decryption, that's DNA decryption. It's not at all what I wanted. Khan Academy, encryption, decryption, and cracking. It's an article that it may or may not open, apparently. There we go. So I'm not going to donate yet, Khan Academy, because I don't know if this is actually going to help me. Oh man, this is gonna be a bit rough, right? This is a pretty big read, and I think we might not have much of a choice but to start looking at that. We'll let this scraper get all of those encrypted strings, presumably. I know that Flux said it might be helpful to automate the scraping of those strings, which we've done. Unfortunately, I don't know if there is a hint within those entries. And certainly I have not done anything about like scraping multiple users and seeing if there's any overlap, because, well, you see how long just one user can take. So having this script, you know, I might as well have it run and then just walk away from the computer for 40 minutes or however long it's going to be. Okay, so it just gets stuck on the last step there and it spits out a bunch of keys. So this appears to be a big batch of information. So I suppose, I think the thing that bothers me the most about this is that they're not at all the same length. And is each one of these a single location, user location? It would kind of match what we've seen with the other, especially with tier 2, right? One user. Cracking one user and getting all their QR codes results in a small number of NPC locations. So this is one user, and there would be a series of encrypted strings we have to decrypt, would give us a small number of user locations. From the very brief amount of reading that I did on encryption and decryption in general, because the length of a string is metadata, right? Like the length of the string can give you a hint to what the string might be. Typically, encryption algorithms will pad it somehow so that you can't tell just by looking at it that's a 7-digit password, right? It could be 15, 20, 30 digits long, even though it's only a 7-digit password. So the varying lengths here is not necessarily indicative that they're not, it doesn't say that they're not just one user lock each. But that would mean that there's a significant variation in the padding that's happening here too. Because if we look at this one's quite short, right? And then this one spans 3 lines. So, all right. So I think what I'm going to do, I'm going to flush these so that we can go and open it here. So I'm opening my user dialog on stream. Okay, I'm just going to... these are going to be under Zyger, maybe? No, it's just under hackmud shell. Okay, there we go. We really just want the last... Oh, there's a bunch of color codes in here. Doesn't really matter, I guess. It is making it a little hard to read. I just want to find where... here we go. Okay, so if we take this all the way down to the bottom, we'll copy that out of here and we'll put it in, not there, scrape, I don't know, whatever, we'll call it just shell text here. Paste it. We have a regex that will decolor for us, so we should be able to just apply that here. Where did it go? Maybe it's in the T3 scrape. Right? Decolor. So we should be able to do these two, hopefully. So I do string replace. I do find that. I have to use escape sequences. Oh my, really doesn't like that, does it? Yeah, wow, it really doesn't like that. Invalid regular expression. / tilde. Jesus. Oh, well, that doesn't matter because that's not the regular expression anyway. I want this, right? I want one or more characters in a group. I want to replace them with $1, right? Did that work? Hell yeah! Replace all of them. Done. Boom. It didn't quite work for... Oh, because those are different color codes. Heh. So this is this will be 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So in here I want A to F, 0 to 9. I want 8 of them. And then the same I think that's it, right? Replace? Not, oh yeah, those are corruption characters. Replace? What happened with my, that one didn't work for some reason because color. You know what? Doesn't matter, because those are just the invitee shit that we don't care about. We primarily are interested in these keys and potentially their associated calendar code. I don't know if there's a relationship between the calendar ID and that means we missed the top one, I think. Yeah, missed this one. So, not sure. So we keep these here. There's the thing. Alright. Don't know what to do with that yet. So that's what we've got. I don't know if this is solvable with the amount of information that we have. So now we've got to read a little bit on encryption, decryption, and cracking. Take a crash course here because I don't really know anything about this stuff. Like, I know substitution ciphers. Those are pretty easy because you kind of did those when you were a kid on the back of cereal boxes and stuff. At least I did. But anything more complicated than that is pretty tough. Alright. One of the earliest encryption techniques is the Caesar cipher, invented by Julius Caesar, or Caesar, more than 2,000 years ago to communicate messages to his allies. The Caesar cipher is a great introduction to encryption, decryption, and code cracking thanks to its simplicity. Encrypting a message. Imagine Caesar wants to send this message. Secret meeting at the palace. Here's what it might look like encrypted. Bunch of gobbledygook. This encrypted message is actually very related to the original text. The Caesar cipher is a simple substitution cipher, which replaces each original letter with a different letter in the alphabet by shifting the alphabet by a certain amount. Shift the alphabet by 6 and use the substitution table. Okay, well, we know that's not it for a couple reasons. So first of all, we have symbols in here. So maybe it would help to look at what symbols are in here, right? Where do we keep a note of this? Here, I guess, right? Hey, could you not open that, please? Kitty? Hey. Hey. What are you doing? My cat likes to open doors when she wants attention from me. She'll just start opening all the doors. I should probably get the HSE up and running here. Hey, I'm looking right at you. Kitty.
Brondo's got
whatever.
Crave.
Yeah, it's got electrolytes.
What are electrolytes? Do you even know?
It's what they use to make Brondo.
Yeah, but why do they use them to make Brondo?
Because Brondo's got electrolytes. Oh, jeez. Okay. All right. So I think we'll keep notes here on what is happening. So we seem to have upper and lower letters, right? Well, I guess we should just say alpha characters. Alpha characters. We seem to have all the digits, 0 through 9. So all digits. We have, I see forward slashes, equal signs. I don't actually see a very large assortment of non-alphanumeric characters. I suppose this isn't a very large sample size to begin with, but it appears to be pluses, equals, and forward slashes only. So that is also interesting in a way. Why just those 3 symbols? Why just those 3? Again, could be a sample size issue, but it seems to be forward slashes, equals, and plus symbols. Jorstra, you're wondering if there's if it's some form of base 64 used with some kind of substitution. It could be like a combination, certainly like a multi-step encryption process. So you would presumably have to, like, what order would you do it in then? Would you encrypt it to a byte 64 string and then shift all the letters? How would you end up with an equals, a forward slash, and a plus? Those could be appended to the end of the alphabet, possibly. It probably isn't a substitution. Or it could be a substitution and a byte 64. I'm not sure, sorry, base 64. I'm not sure if this is a base 64 string at all, though. We can go check. I think we already checked this before, but CyberChef, right? So if we do from base 64, that's too mangled, I think. Yeah, it's too mangled to be some kind of substitution. It only ends with equals equals to pad to a certain length. Could be a step of the cipher. Yeah, it could be. I think we have to, yeah, I'm not sure. I'm not sure yet. It doesn't look like anything, and it doesn't look like it's evenly padded either. So the padding appears to be variable, right? Unless this is, like, there's no way that this contains, right? Like, these ones are too close in size. This one, oh, these two are the same length. I wonder if that is meaningful in any way. But this one is only a few characters more. So that could be one location. It's possible this could be two locations, right? Appended to each other. This could be maybe two locations. They would have to be two really short locations. Oh, the browser's still up. Sorry, my bad. Yeah, like the lengths are a little too close for it to just be, I think, that straightforward. I think there is some variable padding happening. But I don't think we'll know what that padding is until we can decrypt some of it. So like how I did with the QR code, right, is I started reading from the front and just got far enough into it to get the data I needed. And then I just kind of ignored the rest of it. Like even today, my QR reader still mangles the final few data blocks because I don't do the asymmetrically length, like the asymmetric length, block size, whatever nonsense has to be done when you're de-interleaving them. So it could be something similar here. If we can crack the first part of the string and turn this into, let's think about this for a second. Assuming that these are NPC locations, they must have the word, you know, they must have one of the prefixes, one of our NPC prefixes, wherever those went. I think my tier 1 scrape has them, right? Yeah, unknown, anonymous, abandoned. So one of those has to be in there somewhere. So maybe one thing we could try is seeing how many different ways we can transform like anonymous or derelict and see if it shows up anywhere in here, in any of these. So like anon might be the best bet because it'll show up both in anon and anonymous. So we could try, if we go back to CyberChef here, and we do 2 base 64, and we do anon, we get YW5 VBG, right? So do we get YV5 in here anywhere? Not this one. Oh yeah, it is this one. We don't. That doesn't necessarily mean that. That could mean that none of these start with anon, right? So I suppose we could repeat this process with derelict. It could be, I mean, we might not find these. We might not find them, like they won't be just naked like that, right? Because there is something more to it. The very small amount of information I know about this encryption is that it is custom. Like Sean picked something and wrote it. So it wouldn't be a straight B64 anyway. Okay. I think we just have to keep going with our lesson here. So this is how substitution cipher goes. Yeah, I mean, like that. I don't really care about the Caesar cipher. So cracking it. Imagine a very literate and savvy enemy intercepts one of Caesar's messages. The enemy doesn't know that Caesar always uses a shift of 3, so he must attempt to crack it without knowing the shift. There are 3 main techniques he could use: frequency analysis, known plain text, and brute force. Frequency analysis. Human languages tend to use some letters more than others. For example, E is the most popular letter in the English language. We can analyze the frequency of characters in the message and identify the most likely E and narrow down the possible shift amounts based on that. That's not bad, right? So, paste the message in the text area below and analyze the number of possible E's, right? So if we do that, it's going to say Z has 14. So the letter Z here may be the most likely E. So we could try doing that, taking each one of these and seeing what, like, well, basically do this chart, right? And analyze what the most recurring and least recurring characters are in the string. If it's some kind of substitution cipher that could possibly yield some fruit, that's not too hard to do, right? So we could just do that. Oh, we have to have a way of knowing which one of these log entries is a encrypted string and which one is just this typical calendar junk. And I think that might have to do with the number of lines in the response, because the encrypted strings have apparently 2 non-empty lines only. This one has many, that has 2, that has 2, 2, 2, 2, more than 2, 2, more than 2, more than 2. So we could possibly capture, may as well just do that now. So if we can have an array of, what do we call these? Crypt vals, maybe? I don't know. This? We can do, we don't have to log these. What we can do is, actually I want this to be an object, I think. And then we go if response dot filter x to x, because I want the empty lines gone, dot length. Actually, I should probably capture this separately. let empty, not let, we'll just call it r. R equals this. If rr.length is, we're gonna say equal to 2, I think. This is gonna mean that this is an encrypted value entry. Then we will take crypt vals at, and we will do rr at 0, because that will give us the entry key in case we need that later. We should actually probably decolor that also. And then we will set its value equal to rr at 1. And then we can log crypt vals, json.stringify crypt vals, and then return our logs. Okay, let's see what that gives us. So up t3 scrape. I at z is not a function, so not quite. Don't know what I at z is. It's possible that this needs to be split by new line. Whoops, I don't know what I did there. Try that. Nope. I at q is not a function. I don't think that was it either. Does decolor function that way? Yeah, it just takes a string. What comes back from E is I don't think... Yeah, it might not be an array. So I think I do have to do split here. Filter out the empty ones. That's an array. I should be able to do dot length on it. I should be able to do at 0 and at 1 on it. I might have to unminify this to find out what the problem is. Yeah, that's stupid. Alright. Hopefully I have enough characters for this. 38? 90? Nope, I don't. Fuck. I'm just gonna load another char count because I can't be bothered with this troubleshooting. Whoops. Oh, there's a blue char count v2. 26. That'll do. So we'll send Zayajur 26. Load 3. We'll up T3 scrape. And then tell us what the friggin' problem is, please. Response.split is not a function. So... it must not be. Then I don't understand why it won't let me filter it if it's an array. Response.filter is not a function, so what the fuck is response? If it's not a... What is it? It's gotta be something. JSON stringify it. Corp fucking shifted on us in the middle of that's fucking annoying. Alright, well, that's really unlucky timing. So I have to go find another one. Is show.npcs working yet? No. Alright. Scripts.lowsec. And then, where am I? I'm in sector kin lambda 6. Well, I know, Jorstar. It's now core.intern. Alright, it's probably still shifting, though. Nope. Okay. We'll just auto that then and let that go on its merry way. Marto, fix your stuff. Is that that's Matrix's? That's Matrix's user. I should probably ping him on Discord if it's broken. Actually, I don't think I have to ping him. I can just send him a DM. I think he sent me DMs before. Right? Where are you? There he is. Hey, show.npcs is broken. Hey, just wanted to let you know that show.npcs appears to be broken. Passive language. There. We'll see. Okay. So that is not exactly working because I don't want this. I want entry. That isn't a loop. Right, and it's because I'm overriding it every time. So, I should also probably just say, Jorstar said that, show is your user. If it's not, please disregard. Okay, that looks okay. So we've got some key value pairs here. Some of these look pretty damn big. Or maybe it's just the way it's broken up. What happens if I don't JSON stringify it? I wanted to get something that looks like in between these two. I suppose I could just return it, right? That would do it. That's a bit better. It's a bit better. Okay. Again, I only see forward slashes, pluses, and equals. Kitpa. Ja. It seems weird, like it almost looks like this might just be my brain looking for patterns where none exists, but it almost looks like something came out of here. It's probably a coincidence. That's probably just a coincidence. All right. So what we want to do is we want to take each one of these and we want to analyze the frequency of the different characters. So this is not an insignificant amount of work, but what we can do is what's the best way to do this? I can have a string, right? Let chars, and then have a big array of all the chars, right? Would a regex, and then matching the regex, and then the count of the groups be better? Like, if I had a regex that looked like A to Z, 0 to 9, and then slash, plus, and equals. Can I do just a forward slash like that? I should be able to, right? And do a G. That's just going to count all of the... That's just going to count all of them, though. What I would like to do is have this come out and tell me it's an R. Like, I would like it to come out as the result is R. And then, like, chars dot length or whatever would equal number of R in string, right? I don't know if I can do that this way. I would have to... What did I do for conspec? New regex. Right, but conspec is different because you provide it with the digit. So you say, tell me how many zeros there are. This is different because, I mean, I could do this, but I would have to do it in a loop of, again, all the chars. So I think I have to do like A, B, C, right? And then in capitals. And then slash plus equals. Slash equals plus, maybe. Then I would do for let, can I do let char of chars? Will that work? To do characters per character in this string, or do I have to do it by index? For let char of chars, I want to let regex equal new regex. We pretty much just steal what we had here. Actually, we just do this, I guess. Basically just take that conspec p2. I'm wondering if that means we're on the right track, actually, because that's what conspec p2 is, right? It's a frequency detection. It's interesting. So we'll let r equal, and then this will be crypt vals at, and we'll just say the first one. We match char g. If r is null, we'll return 0, otherwise we'll return length. So this would be how many times, this is the frequency of char in the string. Let freq equal, oh, shoulder, it's itchy. So that gives us the letter and how many times it shows up in the string, or the character, I guess. And then we would have to spit this out into, another dictionary. I don't think I want the zeros. I think I do want the zeros at first. I think I want as much information as possible, because it's possible that many of these letters will not be present at all. That would be telling, actually, if there was like never a uppercase Q, for example. That could be, I mean, I see one right there, but just as an example, that could be meaningful to know that it never shows up. So we have to have another dictionary here of frequencies, and we'll have to do freaks at char equals frequency. We're doing all of this. We're going to do all of this in actually, we could do all of this in here. Right? So we can do RR at 1 here. So we can match it. We can set its key. Shit. Cut this, paste it down here. What I want is I want the string, and then I want another object nested under it. That is the frequency dictionary. So this will equal, we'll just say V is this, and then freaks is freaks. And then we can return it. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, slash equals plus. Okay, let's give that a shot. That gave us what we wanted, though it is a little tough to read. Perhaps I should order that array by the frequency, right? So I should be able to do freaks dot sort A, B, it might just be A minus B, right? Does this mutate in place? I didn't read that. Sorts array in place returns a reference to the same array. So I should just be able to do freaks.sort in place and not do anything else to it. Yeah, maybe not. Because it's not an array, it's a dictionary. It's an object, it's not an array. I have to sort them. I can't sort them. I can't. How do you sort properties? I don't know if you can. Can you sort properties? JavaScript. Gript. Sort object by key. I hate those answers. Fuck off, Abraham. Possible duplicate. Fuck off. Can Stack Overflow. Congratulations on your 3 votes, buddy. JavaScript objects don't have an inherent order. Turns out all JavaScript engines implemented more or less the same semantics, so those have now been standardized in ES6. Perfect, because that's what we're using. Use sorted stringify when you need to compare or hash. That's an NPM package, it's not helpful. There's little to no reason why you would do this. Shut up. This, again, I hate when people are like, there's no reason you should be doing the thing that you're doing. Dude, but I am doing it. There's so many times even at work where it's like, hey, how do I do this? I need to do this. Or someone else wrote code that's working that's doing this thing and then it broke suddenly. And the answers are, you shouldn't have done that. Thanks? Thanks, I guess. It's not helpful, though. It's all these non-answers. Object from entries. Entries.sort. Look at that. See? Thanks, Mike Pomax Cameraman's. So should be able to do this. Maybe. I don't know what that will do. Whoops. Apparently nothing. I want to sort A and B by A dot 1, A at 1 minus B at 1. I want to sort them by their values. Did that do it? No. Do I have to make frequencies equal to that? That did it, but in the alphabetically, you assholes. Sort parse int A at 1 minus parse int B at 1. Add a plus here. Because I want to do the reverse. I'm imagining just use plus instead of parseInt. If these are, if it thinks these are strings, though, isn't that just going to concatenate them? Guess we'll find out in a second. Didn't sort them. That didn't sort them at all. I'm not sure what that did. That does not appear to have worked. Because it does this to find out which one's larger by whether or not the number is a positive or a negative number, right? No, do... Wait, what? Do plus... Plus A1 turns it into a number? Like that? Whoops. Nope. Still not, it's working for these ones, but not these ones for some reason. I don't know why. It's only working for the non-numeric keys. says the number 2 shows up in here. Oh yeah, there it is. Try the parsant. I hate writing sorting algorithms. I don't know why my brain hates it. Still not doing it. It is working exactly the same way that yours worked with the plus. So I'll put that back. But for some reason it's not working with these ones. For some reason the numeric properties. Should I do, maybe I should, instead of a char here, maybe it thinks they're numerics, so I'm gonna force them to evaluate as strings and see if that helps. The keys, force them to evaluate as a string. Did that work? No. That's fucking mind-boggling. I don't know why it's doing that. I don't know what the fuck it's doing. Okay. Anyway, it doesn't matter. We have our frequencies. I just ignore the digits. Well, not ignore them, but ignore their ordering. I also want them to be in the opposite order. So I want B and A. Okay. So that gives me lowest to highest on the non-digits, and then I see the digits. 3 is the most occurring one there. This one's very short, and equals is the highest occurring. That's not what I expected to see. Here we have like a 3-way tie between 0, A, and W. This is not looking very optimistic. I guess the problem is that they're user locations and not English, right? So this doesn't help us decipher something that isn't English. How often does the number 7 show up in a user location? I have no fucking idea, right? So I don't know if this is actually going to help us now that I'm thinking about it. Seeing these results. Underscore should show up the most. Not including padding. Yes. This has to, we have to be assuming there's 4 to 5 of them in a location. Yeah. So I mean, we have to assume that there's only one user location in each one of these, and the rest of them are padding. Because, but like some of these are so long, like 3 times longer than the others. I don't know if they're always 3 times longer. Maybe we should also be logging the length here. Just so that we can see that data. So the length can be rr at 1.length. We can see if there's a relationship between the lengths here just by looking at them. 188, 76, 112, 168, 216, 88, 68, 180. There's another 88. 96. 76. Are these all multiples of 8? That would be good if we could find a similarity between these. So 76 divided by 8? Nope. Never mind. Do they have a common denominator though? What goes into 76? 12? 76. Four? Is that the highest denominator? Is 4? 6 doesn't. 8 doesn't. 12 doesn't, right? 14? No. 16? No. And 18. No, it is 4. So 76, I mean 4 is going to be like 96 divided by 4, 24. 88 obviously is divisible by 4. 180, I think. 4. 68 divided by 4. 17. 4. 216, I think it is, divided by 4. Yep, 54. 168 divided by 4. Yep. 112 should be. Yeah. I think we already did 76. Yeah. And 188, I think it is as well. Yeah. So their lengths are all multiples of 4. But that's a very low number, so that's not necessarily helpful. What if, okay, what if, I should be writing this down. Okay, all the lengths are divisible by 4. There does not appear to be any character that's more common than others, right? Because I should probably just minimize this for now. Because for this one it's the number 3, and then we have K, lower K and upper L and 9, like these ones, right? K and L, I guess, would be the next two. For here, it's equal sign and then A and upper D. Where's lower K? Where's lower K? Here. Does that show up at all? There it is, 1. So like it doesn't seem like it's the same repeating character each time. I had an idea. This is totally random idea. Those are multiples of 4. That's why I thought of this. If you take the byte an 8-bit byte. I don't even know where I was going with that. No. Okay, so we did our frequency analysis and that doesn't seem to be panning out. So that's okay. Maybe we come back to that later. I don't know. Okay, so all the lengths divided by 4 are divisible by 4. That's one thing. Okay, let's go back to our guide here. So that doesn't really work because, like you said, Smork, the only one that the most occurring character is going to be an underscore, and they're just too few of them in a user location, right? There's just too few of them. We don't know how many. We don't know enough about these. We don't know how many user locations are hidden in here or not, so we can't really use that to make any kind of determination. Okay, so frequency analysis, known plaintext. Another term for the original unencrypted message is plaintext. If the enemy already knew some part of the plaintext, it'll be easier for them to crack the rest of the encrypted version. And we do know some of the original plaintext, right? Because we know the prefixes of a user location. So this might do something. So for example, messages tend to start with similar beginnings. Right? In World War II, encrypted German messages always started with a weather forecast, which ultimately made it easier for British mathematician Alan Turing to crack. Do you think Julius started this message in a common way? Yeah, I don't know. So, unfortunately, it doesn't really tell us anything else other than that maybe we could be looking for a similar start for some of these. Look at these. Y9TTK. RMP. Y9TTK. There's another Y9TTK. So 3 of these start with Y9TTK. That's interesting. Does Y9TTK, how often does that show up here in our data? Where did I put it? Here? Oh, these are old values. Frig. I wanted to copy these. I want to copy these all, please, into here. What could Y9TTK be? RMP. Y9TTK is 5. Do any of the... Let's close some of this stuff here. Do any of these start with just 5 letters? None of them start with 5 letters. That one is 6 and this one is 4. Anon underscore? Yep, that's true actually. Y9TT. So how often the question would be, why is the ends, why is the first N a 9 and the second end a T? If the letter shows up differently depending on where it is in the string, that's going to be incredibly difficult to locate that way. A vinegar cipher? I don't know what that means. What's a vinegar cipher? A Vinger cipher, is that what you're talking about? You totally butchered the spelling. The next character depends on the previous one. Oh, it's because it's based off of... So the Vinger... Vinger... The Vinger cipher. Is this the one that you were talking about, Smork? So there is a key. There's a key string for it, and then you shift it based off of the position. So that's possible. The only problem then is we have no idea what the key might be. I suppose we could look and see at what we have to do to shift these letters to be anon, and then see if we can reverse engineer that. So like, let's assume for the moment that Y9TTK is anon underscore, right? So let's assume that Y9TTK is anon underscore. I don't know. I'm assuming these would be character code. Oh, you know what I should do? I should also bring up the ASCII, ASCII table. I don't remember my ASCII codes. So it goes uppercase, then lowercase. So it goes plus, / equals. Actually, it goes plus / the numbers, then the equals sign, then uppercase letters, then the lowercase letters. Is that the order? Do you think that's the order they're going to be in? The decryption key order? That would be their order that they show up in the ASCII table. So I should be doing here, I should be doing, what was that? Plus / numbers starting at 0, plus / and then the uppercase letters, and then the lowercase letters. Oh, 8, 9, and then equal sign. That's in the ASCII order. That order there is irrelevant for, well, maybe it's not. Maybe we can use that again down here. So to get from A to Y, we do -25. I suppose we'd know if the distance between any of these letters is more than 26, because then the key then the so if I want Y9TTK, if I want to get the distance between each of these characters, I would have to do chars at Y index of, can I do, let's start index. What does this do? How do you do an index of in JavaScript? Is it literally just index of? Why was it not showing up there? All right. So we do chars.index of, and then we do Y. Minus chars.index of A. And then we repeat this for all of these. Underscore's not in here. Fuck. How do we know where underscore is? Okay, if we assume that... Okay, forget the underscore, right? Let's try this. This is only going to give us 4 letters, though, so this may not do much either. But if this is like the word hack, maybe that's a clue. So we'll do Y9TT. Am I doing this correctly? I don't even know what I'm doing here. We're gonna have an A, a B, a C, and a D. And then we're going to just return A with A in it, B, C, and D. Whoops. Okay, whoops, Jesus. See what this does for us. Heh. I don't know what's going on here. Do I have an A somewhere else where I'm not supposed to? C1, C2, C3, C4. Chars is not defined. Oh, I've defined it in here. Shit. C4 is not defined. Ah. Getting sloppy. 24 minus 41. 21 minus 21 minus 20. Try to abs all these values maybe, and see if that gives us (24, 41, 21, and 20). So what happens if we do chars at these ones? So this will give us the, I mean, this can't possibly be right. Because we need an underscore following this method. I think I'm chasing some weird rabbit hole here. Because none of these values would be characters in the ASCII table. Yeah, I don't know what to do with this. We need a way to transform an underscore somehow into something else. How would an underscore become a character once it's encrypted, but none of the encrypted characters are underscores? How does that work? I suppose one of the symbols could be an underscore. So we have underscores and we have dots, right? In the locations. So that's 2 of the 3 symbols. So an underscore could be an equals and a dot could be a plus. I don't know what the / would be though. A user lock only has 2 non-alphanum characters in it, underscores and dots. I don't know what the other character would be. A comma? Locks also don't have capitals. Yeah. I mean, that doesn't mean that the decrypted location, like the solution might be you do a 2 lower on it, right? That could be one of the steps of the encryption is you randomly shift any of the letters to upper case, just like randomly. Or if it's like some kind of ASCII shift, it could shift them into the uppers if they go negative enough. I have no idea, because we have no idea what the key is, right? So it could be anything. It could be anything. I know that there's a book cipher, and that's like you just have like someone could have some textbook on their desk, right? I don't think it's that mean. I don't think this one's particularly mean like that, but it could be anything. Could be literally anything. Could be the words Sean is the best, right? I mean, that looks good though, but it's just I'm not sure if that's enough to tell us that the rest of this is one location. I don't know. Anyway, we've got an ad, so I'm gonna take a break, stretch my legs, bathroom, you know the drill. I will be back in a few minutes, all right? Okay. Alright, I'm back. Thank you for waiting. I think I saw Twitch only launch a 1-minute ad, which is a little weird. But, whatever. You do what you want. So I had a thought whilst I was walking. So, why 9TTK? Get any closer yet? So, Smork did point out that, you know, we saw a pattern here. So when we were looking at the decryption guide or whatever, and it says look for plain text stuff, so repeating patterns. We did notice 3 of these strings start with Y9TTK, and Smork pointed out that that could be ANON underscore, right, as the start of a location. However, obviously, it's not just a straight substitution because the first N is a 9 and the second N it would be a capital T. So it is Smork then also suggested it could be a Vignere cipher, which is that there is a key that you use to shift, so each position is shifted by a different amount based off of the position of the letter at that space in the key. So I don't really know what to do with that. I was doing some nonsense here. I don't really think I'm going to do anything with this. I think what I want to do is I want to take the ASCII values of these. So there's a from char code. Is there string from? Is it? What is it? From char code to char code. I don't remember what it is in JavaScript here. JavaScript from char code. It's just from char code. And then there's to char code, right? Char code at a specified index. Char code at a specified index. So I would do like I could do Y char code at and then 0. Array dot from out split out dot split what's out in that example? I just wanted to see what the char codes were. Out is a string that the location returned. Yeah, all right. Let me take this. So if we do, so let's comment this out for a second here. Actually, let's just get rid of all of this because it's crap. I don't think that's going to go anywhere. So in here, I want to do what do I want to do? Codes, and then codes can be equal to array.from rr1, which is the value, split it by nothing, string.split, c.charcode at 0. Okay, so that should do it. You were splitting on space in your first example? Okay, so we want to split on nothing because we don't have any spaces in here. Okay. So let's see what this gives us. This is going to give us a big, huge array of for each. What happened there? It gave us an array with one entry. Creates an array from an iterable object. We're doing response.split. Split with an empty string. Okay, well maybe that's... So let's just return the first element of crypt vowels then. So splitting out the whole object is too much, but splitting out the first element is nothing. How about I just do that, except I use crypt vowels at 0 here to just do the first one. Huh? The fuck? Is this still returning the right shit? Yes. But for some reason, if I do crypt files at 0, what do I get here? Nothing. I don't understand why that would be happening to me. This is a fucking object. Oh, because it's not an array. I want object.entries at 0. Is that what I want? I want the 0th entry. Ah, all right. That's why. So if I do this, whoops. If I do this, and I do the 0th entry here, and I do the 0th entries V, that should give me the codes array. Fuck off. Ah, Jesus. Okay, so these are all the char codes for this string. I want the one that starts with Y9TT though, so I actually want element 1 here. And I wish that this would... it doesn't fucking matter. It doesn't matter. Okay, okay, so this is, I think, element, the second element was a Y9TTK. So what this is a Y9TT, well that can't be right. Oh, that's the wrong entry. Yeah, there we go. So Y9TTK. So 121, 57, 84, 84, 107. Great. It's just a bunch of fucking numbers. There was something I wanted to do with this. Yeah, see, this is the problem, Smark, is I didn't want the whole thing because I don't know what any of the rest of it is. if our theory is correct that this is a non, the next thing after the underscore could be literally anything. And we have no way of guessing it, right? So for the plain text, I think I just want the first 5 of these. Man, I kind of lost even what I originally came back from my break with. Now, what my idea was. I wanted to know what the ASCII character was for Y and the ASCII character for A, and then I wanted to know the difference between those two. So I think okay, I'm just comment that out. I think what I wanted here was so I can just do Y dot from char code at 0, right? Minus a char code at 0. And I want from, what was it, to char code? Char code at from char code. String dot from char code. Static method. Y minus A. So this will give us the char code at the difference between the two. Some unreadable character. Well, there was that idea. I suppose I could reverse them. A minus Y. That's going to be negative though, I think, right? Also unreadable. So the difference between these char codes is not itself a char either. I mean, that looks, it could be static padding. Like it could be like a false lead, right? It could be static padding. What were the crypt vowels again? We also had RMP. But that's only 3 letters, and none of the user locations start with just 3 letters. Do they? Maybe 3 of the same letters? UNK and UKN. ABN and ABAN. Not really. Those could be anons as well, but with a different shift. It could be anything. I'm not really super confident that this Y9TTK is anything more than a coincidence. I don't like that because it does show up 3 times in here. They're not even the same length though either. Like they both start with Y9TTK, but this one's 180, this one's 112, this one's 96. So it could be pre-padding. RMP. Like RMP shows up, but it's just RMP. Scrape another corp. I need more data. Do I need more data? If the key... What if the key is the calendar entry? Why 9 TTK, man? That's a lot in common, though. That's a lot of characters for 3 of them to be Y9 TTK. Are you suggesting, Smark, that I scrape something else and see if I get Y9 TTK in a bunch of more places? I mean, that would be a sign that is probably not a coincidence. It doesn't necessarily mean that it's data. It could be padding. But it would be more than just a coincidence, I think, at that point. Okay. So what I can do... is I can have my scraping, or more similar prefixes. Okay, so the important thing is that I capture these. So their lengths are not super important right now. I just want to capture them. Okay, so I'm going to copy all of these in here. I guess I already had them. It doesn't matter. So capture all those in here. Make sure I clean these up a little bit. I suppose that's a little bit easier. Okay. What I can do is I can add, so in here I did something like this originally on my tier 2 scraping, is I returned the index of the user that it matched, and I let someone, myself, I could supply a different value to say, hey, start at this index of the user's array and keep going. So I could scrape a different user from the same corporation. So I think I'm going to do the same thing here. So what I had was an a.I in here somewhere. So we will do... Where are we doing this? Let's minimize this for a second. Minimize this. Minimize this and this. Minimize this, minimize that. If user is not found, here I think I want to do let user I equal a.I or 0. I have to return I. Well, I can do that later. Oh, Jesus, that's not what I wanted to do. Username's at user.I. Username found this, user I. I already know this one was Robert Marley, I think. So I could just put I equals 1 here, I think. Right? Yeah. So I should be able to go non-continuation token true. I is 1. There. Okay, and we'll let that go. And we'll see what it spits out at the end. While that's running. So that's the plain text method that we're entertaining here. Brute force. There are only 25 possible shifts, not 26. Why not? Because obviously that would shift all the way back around. The enemy could take some time to try out each of them and find one that yields a sensible message. They wouldn't even need to try the shifts on the entire message, just the first word or two. So we can't do that because we know it's not just a straight substitution cipher. It's not a Caesar cipher, we know that. So we can't really brute force it. We understand 3 aspects of data encryption. The encryption, scrambling according to a secret key. Decryption is recovering the original data, and code cracking, uncovering the original data without knowing the secret by using a variety of clever techniques. Whenever we consider a possible encryption technique, we need to think about all those aspects. How easy is it to encrypt? How easy is it to decrypt? And most importantly, how easy is it for a nefarious individual to crack the code? We can no longer use Caesar cipher to secure our data as it is far too easy to crack, but understanding it prepares us for understanding modern encryption techniques. Okay? So, symmetric encryption techniques. So here's the Vignere cipher. So symmetric encryption is any technique where the same key is used to both encrypt and decrypt the data. We don't know if this one's symmetric or not. So the Caesar cipher is one of the simplest symmetric encryption techniques, and of course one of the easiest to crack. Since then, cryptologists have invented many more symmetric encryption techniques, including the ones used today to encrypt data like passwords. The Vignere cipher. French cryptologists invented the Vignere cipher in the mid-1500s. The cipher was considered especially strong, and author Lewis Carroll even called it unbreakable in 1868. It was indeed much stronger than the Caesar cipher, but as we'll see, it can definitely be cracked. The Vignere cipher uses an entire word as the shift key, as opposed to the Caesar cipher's single shift. Imagine we want to encrypt the phrase Versailles and use the shift key of cheese. We repeat the shift key and line up each of the letters in the phrase. We repeat each letter of the original text according to Vignere table. The fuck is a Vignere table? They lost me between those two sentences somehow. Repeat the shift key to line up with the letters. Replace each letter according to the Vignere table. Oh, there is a Vignere table. So you find V, you go down to the letter C, and you put X. Gotcha. Again, this, we know it's not a Vignere because that is not a unique encryption. That's just Vignere, so it wouldn't be that simple. And this doesn't work past the standard alphabet. I suppose again we could have the whole ASCII string in both directions, but we have slashes, pluses, and equal signs that we have to worry about, and we only have 2 non-alphanumeric characters in a user location. That is an underscore and a period. So there isn't a third. It's probably not symmetric, just based off of that the possible characters are not the same in the decrypted data as the encrypted data. I don't think. We receive the encrypted message. We know the cipher is cheese. Oh, okay, let's stop here. I don't see anything that looks familiar in any of these. That's not great. I do see a QV. I just see Q and V. That's too short to be meaningful. That sucks. So that's not great for us. So the plain text thing may be bogus. Like, we might not get anywhere with that. I can't believe that would be a coincidence, though. That seems like a pretty nuts coincidence. But then again, we don't know anything about the encryption method at all. So there could be something in it that is repeatable, and we don't know, right? So SEV, I don't see, like, we had the R9M, RMP, none of these. There is not, okay, so right here, I see a wider variety of string prefixes than we have NPC prefixes. Look into the length of the strings again. Is the length of the cipher -4 equal to a non-p info length, for example? I mean, I can go back to spitting out the length for these. No problem. All divisible by 4. I said minus? Oh, sorry, my bad. Yeah, no, yeah, I saw it divided by 4. They are all still divisible by 4. So that is not a coincidence. Is the length divided by 4 equal to a non-DDV Weaver, like an NPC name, right? The only problem is I would have to check all the... Okay, two problems. One, I would have to check all the combinations of prefix and postfix, right? Because all the prefix of the locations are also variable. And secondly, if there is a tier 3 user in here that's not an NPC, like half of these could be tier 3 users and not NPCs, and that if we could really get stuck on trying to figure out which one's what. So I don't know if, like, that's a good idea, Smork, that's a good idea. I just don't know, because there could be users in here. We might really be bashing our heads against the wall trying to figure out which one of these are a player and which one of these is an NPC. So Joestar, technically it could be base 64 encoded, something that is shifted. But that's just speculation. Because it's using the same characters doesn't mean that it is. Yeah, I don't know. Yeah, I mean, it could. That's the problem, is it could be anything. And yes, there could also be nulls, and yes, we don't know if these potentially are more than one. Like, are these longer ones actually 2 or 3 user lokes? All combined into one result. We don't know that either. There's a lot of unknowns here. The length, though, being always divisible by 4, is not a coincidence. So we know that for sure the length is always divisible by 4. Well, not for sure, but we have a pretty large enough sample size. I think we can say that with some confidence. The length is always a multiple of 4. Does that mean maybe that it has to do with every 4 characters. How does the number 4, you take it in 4 character chunks, and each 4 characters represents 1 letter in the location? Again, because we don't see, because there could be users in here, we don't have a good way of recognizing a pattern. I am noticing there are some repeating patterns in here. R3VFR. And there's actually, it's equals, actually it's more than that. It's 4B3L equals R3VFR. And it's repeated here. How many characters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's V as well if you don't count the case on it. Oh, the browser's still open. Sorry, man, I'm so bad at that. So, yeah, so this is repeating. It repeats here, 4B3L equal R3VFR. They're almost right next to each other too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's interesting. So this sequence is 10 long. And the space between them is 10. Again, could be a coincidence. Can we find any other repeating patterns of 10 characters? So how do I do this programmatically if this is my next theory? The length, though, is a multiple of 4, not 10. So that would mean that there is padding at the end. Like this one would be 20 characters long with 4 padding. Maybe it pads it to a multiple of 4 length. So this one would be 16 characters long and then padded to 4. This one would be 9 characters long and then, or 8 characters long and then padded to 4. This one would be exactly 10 characters and requires no padding because 100 is already a multiple of 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What a 10 character user location would be. 1, 2, 3, 4, 5, 6, 7. That's not even enough characters for a location. 10 characters. It could be MISSING and then 2 angle brackets. That's only 9 characters. The shortest possible result we could get here is null, right? Angle bracket, null, angle bracket. That's the shortest one that means that it's missing. That's 6 characters, which means that the minimum size would then be 60. Which is not divisible by 4. It would have to be 60 divisible by 4. Yeah, yeah, it is. Yeah. It's 15, right? I think it's 15. So the shortest length we would see is 60. If that were the case. Oh, there's too much history there. I can't scroll that far back. Are all of them divisible by 6? No. No. So we already tried. We tried every even number, and 4 was the highest one. That could be a coincidence, or it could be like I don't know. It's right now it appears to be the only thing that's common between all of them is the length is a multiple of 4. And this pattern that we saw here, the one 4B3L equal R3VFR, is 10 long and has another 10 characters between it before it repeats. So that's like a theory. We don't know what the relevance of that is. We would have to go and search for other 10 character repeated strings. But I'm worried about that 10 characters because like this 72 length one would only be that would mean it's only 6 characters and then padded to a length of 72, which would be null. That would be null. Maybe there are multiple variations. Yeah, I mean there could be multiple variations too. If it were 10 character, we should see NULL would show up. LL would show up twice in here. The last 10 would repeat. No, it wouldn't, because it's padded to 72. So you ignore the last 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you repeat from the 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope. Yeah, like it could be a variation, so the length is specified somewhere else. Fuck, it could be fucking anything. This could be like a 20-step decryption, like we have no idea. The first step could be like pick a letter in the alphabet. Then use the ASCII character of that divided by 10 rounded up to determine the length of the... Like, it could be fucking anything. It could be, if it's a custom encryption, it could be fucking anything. It could be any number of steps. This isn't the first time we've seen a repeating pattern though, right? Because like this pattern, we saw a 5-character repeating pattern at the beginning. Well, it wasn't a repeating pattern, but we saw the same 5 characters across 3 of the different strings. Maybe the length of the segment is variable, but there is always a segment. And so if there's always a segment, most of the NPC locations will have a duplicate letter in the beginning. There's N's duplicated here, 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 and here. This is the only one that doesn't have an N, but it does have a duplicate E in the first few characters. I could write code to start. God. That would be a rough piece of code. So it would start at 2 characters, I guess. Fuck, I don't know. 2, I guess. Could be anything. And check for... It would have to increment by 1 and check... Okay, take these 2 characters. Do they occur anywhere else? Yes or no? Okay. Then take these 2 characters. Do they occur anywhere else? Yes or no? And go through the whole string that way, 1 index at a time by 2. And then do the same thing, but do with a length of 3. Go up by index by 3. And do that until it finds a repeating pattern. Until it finds a recurrence that matches one of these. Like finds an N, blank N, blank blank N, right, for unknown. Or an N blank, yeah, or just N blank N. N blank N. Actually, if it found N blank N, it would capture most of these. That'd be N blank blank N. Like, fuck, man, that's a real shot in the dark. What if the length of the string has something to do with decrypting it? What if that's part of the key? If we divide the length by 4, right, we'll get a whole number. Maybe it's how many times 4 goes into the length of the string that has something to do with it. Feels like a real big stretch too. Like for this one, the number would be 25, right? To come out of this one would be 25. And we do something with the number 25. I don't fucking know. What? What do we do with the number 25? What would 72 be if we divided that one by 4? This is the shortest one. Like I feel like this one is the word null because it's so short. (72) divided by 4 is 18. What does 18 mean to us? Nothing in the context of this string. I have no idea what to do with the number 18. Can't shift each of these letters by 18. That doesn't fucking do anything. There's too many letters. This could also be a location. And it has nothing to do with it being so short. Honestly, like... Okay. Let's just read some more stuff here. So the Vignere cipher is a type of polyalphabetic cipher. It's a harder code to crack than the Caesar cipher due to using an entire shift word. If an interceptor had no idea what the shift key was and wanted to brute force their way, they needed to try out all possible shift words in the world and perhaps even made up words. For a mere mortal, that could take a lifetime. What about frequency analysis? Do messages encrypted with Vignere cipher have a special pattern? Okay, let's try this. Encrypt. The original had 37 E's. That seems to be the answer is no. The frequencies in the encrypted messages are more similar to each other. We can't identify an obvious E, because the letter E gets encrypted into different letters at different points in the message. Yep. In the 1800s, people finally figured out different ways to use frequency analysis to crack the cipher. For example, in a long message, a short word like "the" may get translated to the same 3 encrypted letters multiple times, just not every time. And that reveals possible links for the shift key. Now that we have use of powerful computers, the Vignere cipher is relatively easier to decipher because a computer can quickly test out millions of words. Yeah, well that's with brute forcing though, and we don't know that it's a Vignere cipher, so doing all that work to brute force it is not going to really help, I don't think. In the age of computers, ciphers can't just be hard to crack by an enterprising human, they have to be hard to crack by a computer that can do trillions of calculations per second. Or however many you can do in 5 seconds for us. I suppose I could like spin this out into a C# program so that I have an unlimited execution time trying to decrypt them. That might not actually be such a horrible idea now that I'm thinking about it, because we could write something that brute forces something, and we have access to some of the built-in encryption stuff that comes with .NET. But I don't think it is like an AES decryption or anything like that. So send the cipher to a chat message and use the API to decode it? Oh god. Please don't. I mean, yeah, I mean I could. If that were how to do it. Yeah, absolutely. I could also just like build the T3 scraping into a C# app instead. Send a tell to my user. Yeah. I don't know if that's actually going to work. So like I could try, right? Like one of my theories here, and I don't think this is it, right? Would be to have this key, and we do AES decrypt, and for the key we use the calendar entry. Invalid key length 6 bytes. So AES is to secure, I guess, right? Length of 6 bytes. Invalid key length of 6 bytes. I don't actually know how any of this shit works, so it's not. I don't even know how this stuff works anyway in theory, so I just figured maybe that was a key. Decrypt. Nah, I don't know. It's a waste of time. I mean, you're joking, right? Like Jorstar, you're joking about sending it through the chat API, but that would work if I could figure out how to brute force it and I needed more execution time. You're not wrong. Not wrong. So I don't know why NuGet would be flagged as a I don't know why. There must be some slang that I am not aware of. Is calling someone a nugget, like, is that is that offensive? Maybe that's British. That sounds like British slang. You nugget. Anyway, It's on the permitted term list now, so. Alright, gotta love AutoMod without filters. Yeah. I had to use the defaults. I couldn't be arsed. So, alright, I guess we just have to keep going. They're about to explain AES, I guess, here anyway, which I don't know, so okay, in the age of computers, yeah, they gotta be hard to crack by a computer. Cryptologists have invented encryption techniques that are secure in the digital world and are continuing to improve them every year. One of the most common encryption standards is AES 128, a block cipher approved by the federal government, which federal government, and used, I know it's the American one, used often for secure file transfer. On default, it would be the best. It would still be best on minimal. Yeah, we've had bots, remember. We have had bots in here. Though they haven't been offensive bots. They've just been trying to sell things. Alright, so what makes it so secure? One reason is that each key is always 128 bits long. That means there are 2 to the 128 power possible keys. Wow, but wait. So yeah, I guess what we were trying to do was 8 times 6 bits, right? R9K is for bots. I don't know what is R9K? Eh? I don't know what that is. But wait, there's more. The AES cipher requires applying a sequence of 10 mathematical operations for each bit of the key. Multiply that number above by 10, and that's the number of calculations a computer would need to do. R9K stops repeated messages. Yeah, these are like the bots that come in though and are like, hey, I just noticed that you need more viewers because you suck at Twitch. We can sell you viewers or whatever. They just post the one message, but I don't want that crap in here. They've gotten through before I have to block them manually. Anyway, I don't care. The chat's not disruptive enough. Yeah, I just ban them one at a time. It doesn't matter. I don't. Moderation takes up like no % of my time right now, so I don't need to play with those filters. When someone calls me a nougat, then I just ban them. So don't call me a nougat. Okay, so frequency analysis won't work. The AES cipher does not reveal any information about the original text because of a multi-step sequence of operations on blocks of bits. So it could be something like that, and we won't see anything through frequency analysis, which is kind of what we were seeing. Some of the other ones, like we saw, like some of the characters would show up much more frequently than others. Like we would get one of the characters would get a hit of like 12 repeats in a string, but we know it's not a straight substitution cipher, so saying that must be the letter E, for example. And also, that's like frequency analysis for like the English language, right? E is the most common letter in the English language, but we are not looking for English language here. We're looking for a location, and we don't know what the frequency for location characters is. Presumably, except for like the prefix and postfix, all the inside is actually, that's not true, right? TTL we'll see more often than anything else. Because we'll see JR and we'll see TTL very frequently, but that's a lot harder to find on a frequency analysis because there are multiple characters. Yeah, it's still we just don't have enough information. Anyway, I think I have to just learn more. This is all symmetric encryption, right? Which this may also not be symmetric. So AES ciphers may not be secure forever. We already know that. Yeah, cryptography research is done in the open. Okay. So the Pigpen cipher is a simple substitution cipher originally invented in 1500 and was particularly popular with Freemasons. The cipher key is based on drawing the letters of the alphabet inside lines with circles. I think I've seen this before when I was a kid. When encrypting a message, the sender draws a relevant line and dot combination without the letter inside. For example, here are 4-letter encryptions. Oh, we've got an ad coming up. I'm going to snooze that because it's getting late anyway, so I'll get a few snoozes in here and then we'll end the stream. We have not really made too much progress, unfortunately, but some of this is like, I just have to learn. So, like, I don't know if it could be some kind of variation on this or not, where each one of these symbols would be represented by a combination of letters. So like this could be like as an L. You know, I don't really think that's it. I'm not sure that that's it either. Public key encryption. I mean, we should just read it anyway. So on the internet, two computers often want to exchange secure data with each other. I type my password in Khan Academy login screen. I want my computer to send that data safely to the Khan Academy servers. I do not want to worry an attacker might be monitoring my internet traffic and watching the password go across. Symmetric encryption techniques rely on both the sender and receiver using the same key to encrypt and decrypt the data. How can my computer and the Khan Academy server exchange the keys securely? If an attacker can see my password go across the wires, then they can also see an encryption key. Public key encryption to the rescue. It's an asymmetric encryption technique which uses different keys for encryption and decryption. So that could be something that we're looking at here as an asymmetric encryption. So this allows computers over the internet to securely communicate with each other. Let's step through the high-level process of public key encryption. Let me take a sip of water first. Alright. So key generation. Each person or their computer generates a pair of keys that identify them, a private key and a public key. Generate a pair below using RSA algorithm that's used by your computer. So those are quite long, right? Those are quite long keys. That's not to say that this couldn't be using something similar, but I have a feeling if it generated... See, what we need, if this were the case, is we need something that's generated based off of a seed. And I would think that the seed would be the calendar entry. If anything, that would be my assumption. But I don't think these RSA keys, I think they use time seeds. Maybe you can use them with a string seed? Probably not, right? Because the whole point would be to not generate the same key every time, because then someone could just brute force the keys. Their algorithm repeatedly generates random large numbers and checks if they're prime until it finally finds two random large primes. All the checking for primes can take a while. The keys are only 512 bits long. The current nationally recommended key length is 2048. So yeah, we would generate... I don't even know what we would generate there. So I don't think so, because that sounds like it's based off primes and not a seed. The receiving computers exchange public keys with each other. The private keys are never exchanged. The sending computer encrypts the secret data using the receiving computer's public key. The power of public key encryption is that in the mathematical operation, it's a one-way function. Well, I don't think that that's it then, because this wouldn't be a one-way function. That would make it, in theory, we have the calendar string. Yeah, but like, so like the calendar string over here, right? That could be a seed, but I think that from what we're reading here, that this is the PGP keys essentially are, or whatever, like these RSA keys that they're one-way encryption. So, like I mean, presumably it could be the public key. So the calendar ID is the public key, and then you use that to decrypt. But, like, how? Because you'd have to use, like, this doesn't explain how the RSA algorithm works to apply that key. And I don't think it's RSA, right? You think this is more like a sort of hash rather than encryption? Yeah, I mean, it could just be a hash. But, like, how is it applied, right? Because we already looked at, is it a multiple of 6, right? Because maybe you take each letter and you shift the letter by each letter in the key, and then you pile them all up to each other. I mean, certainly the padding could be based off of the padding could be a multiple of 4, so it could pad to a length that's a multiple of 4, and the key could have something to do with every 6 characters. But I would expect to see a whole lot more repeating sequences if that were the case, right? Because that would mean these 6 characters here would be a hash of the letter that's supposed to go there against this 6-character key, which means that I should see this showing up all over the place. I should see repeating patterns of 6 everywhere. The only repeating patterns we've seen right now are of 5 and 10. I could write a whole bunch of code to go through and brute force these and look for repeating patterns of any length between like 2 and 12 or something. But that'd be a lot of work, and it may not actually result in anything. I mean, maybe I'll have to, because, like, you know, how much time have we been here for? 2.5 hours, and we have not really gotten anywhere. But, like, that's an option that, like, maybe it's a hash. Maybe the calendar entry value is a hash of some kind. Might have to search for variable length patterns in the encrypted strings. Alright, this is our last snooze, so we've got 7 minutes, and then we're going to end the stream. So you send something with the person's public key, they decrypt it with their private key. So once you encrypt it using the public key, it can't be decrypted except without the private key. So it may sound too good to be true that it's possible to encrypt something with one key that it can only be decrypted with a different key. For a long time, mathematicians weren't sure if it was possible. Fortunately, they discovered a way in the 1970s. The math of a one-way function relies on prime numbers, the difficulty of factoring large primes, and modular arithmetic. If you'd like to dig deeper into the math, blah, 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 fortunately all of us can use and benefit from public key cryptography without needing to understand the math. Okay, public key encryption. Inventors did not anticipate it being used widely due to the additional time required, much more than symmetric encryption techniques. However, with modern computers, public key encryption is feasible and commonplace. Okay, doesn't really help data encryption techniques. That doesn't really give us anything here. Do 4 problems. Sorry, can we skip this? Skip questions will count as incorrect. Yeah, that's fine. I'm not at school here. Yeah, next question. Oh, these are just questions. So this is just a quiz. That's a quiz. So this is computers and the internet, data encryption techniques, secure internet protocols, user authentication, collaboration, crowdsourcing, monitoring, core SAM. So that's Khan Academy. Told us a little bit about some of them, but I don't think that any of those are necessarily what's going on here. Describe the process of decrypting a ciphertext using the DES algorithm. Maybe it might be worth reading this. Process of decrypting a ciphertext using the DES algorithm involves several steps essential for recovering the original plaintext. DES is a symmetric key block cipher, meaning the same key is used for encryption and decryption. Decryption process is essentially the reverse of the encryption. It requires the same key. Key schedule. The first step is to generate the round keys from the original encryption key using the key schedule algorithm. It takes the original 64-bit key and produces 16 round keys, each consisting of 48 bits. These round keys are used in subsequent rounds of decryption process. So, yuck. The decryption process consists of 16 rounds, each of which performs a series of operations on the ciphertext using the round keys. In each round, the ciphertext is divided into two halves. Oh, God. I really hope that's not it. In each round, the right half of the 64-bit block is expanded to 48 bits using expansion permutation E. The E permutation table is used to determine the... I'm not fucking figuring this out. This is not... Wow, imagine I have to do something like that. Generate a bunch of keys off the original key, and then do 16 manual rounds of decryption using the 16 keys that I've generated. Sheesh. Encrypting and decrypting a message using symmetric keys with Java. Using an AES encryption scheme to perform encryption and decryption. Generate a key using AES. Key size can be different bytes. We don't have that. We have 6 bytes. I mean, it could be a 6-byte AES algorithm. I'm not even sure if that would work. It's not, though, right? It's not. I don't think that's it. So, I mean, we're just about out of time for tonight. We have the code for frequency analysis here. So, that's not a total loss. We're calculating the length, and we did notice that they're all multiples of 4, which is not, again, not a lot. And not anything obvious. We did see some keys that either started with the same 5 characters like we saw in these 3 up here, or we had the one in here that had a sequence of 30 characters with the first 10 and the last 10 being identical sequences. But we don't understand the significance of any of those things right now. Or if they're significant. They could actually not be significant, right? They could just be coincidences. When you're using... What do we have? We have 26 letters in the alphabet, so that's 52 letters in lower and upper. The 10 digits is 62, plus 3 more is 65. So we have 65 characters that are used here. I don't know if that's relevant in any way. 65 characters in total. I don't know. Anyway, don't want to end on an ad, and I'm out of snoozes, so I think that's going to be it for tonight. So I will be back again tomorrow for regular stream. We'll just pick up on this, and maybe we'll be able to get a hint on where to start looking for this, because I'm feeling pretty stumped right now. So thanks everyone for coming. Jorstar and Smark, thank you for your help. If you enjoyed watching me absolutely fail at encryption, just as advertised, please give me a follow. I'd appreciate it. Otherwise, I hope to see everybody tomorrow. Have a great night, and have a great day, and whatever. And just be good, and everyone take care of each other, okay? All right, thanks. Thanks for coming. Have a great night.